Hello, I'm Elias, and today we're going to talk about cost risk analysis. First, project risk analysis takes into consideration the uncertainty factor associated with the project final cost and schedule. This process starts early on in the planning stage and continues to the project execution phase, and data should always be refined as new risks are identified. The analysis required gathering data about the project through conducting interviews and past experience in similar projects. The analysis helps stakeholders to provide the needed budget for the project while keeping an eye on the risk associated and how to mitigate it. First, the three-point estimate is one of the most basic risk analysis approaches which requires us to allocate for each line item three values which are: first, the value for opportunistic estimate, which is the smallest value to complete an activity. The second value is the pessimistic estimate, which is the highest value to complete an activity. As for the third value, which is the most likely estimate, which is between the other two estimates, statistically this is the mode of the distribution. The three-point estimate curves, as you can see here, and it's a little bit skewed to the left, which helps us later assume it as a beta distribution. For example, beyond the opportunistic and pessimistic values, the probability is almost zero, which is not quite accurate, but again, this is an approximation. The method of moments, it's also called PERT cost, since it uses the assumption of PERT. For the mean, which is a highest value plus 4 times the most likely plus the lowest value over 6. As for the variance, it's the highest minus lowest value over 6 squared. By assuming each line item has a beta distribution, and by using the central limit theorem, we can assume that the final cost of the project is normally distributed. In order to calculate the mean and variance of the total project cost, we will use the PERT approximation as we have already stated. Moving to Monte Carlo simulation, which is a technique that can be used in any forecasting model, including cost, which helps us understand the effect of risk or uncertainty on the model. The simulation software conducting Monte Carlo will run and iterate different possibilities of cost for each activity, and then sum them up in order to obtain a total project cost. Monte Carlo creates different project alternatives, which one of them might be our actual project. The software will choose a random value between 0 and 1 for each activity, and then get the total cost for this line item, which is basically our first iteration. The software will keep iterating until they can create a distribution for the project total cost. After getting the distribution of the project total cost, the project manager can choose a certainty range, for example 80% certainty, and then he can get the associated cost with this certainty level. Moving to sensitivity analysis, it helps us answer the following question: which risk item is the most important one and has the most impact on the project total cost? The contractor starts the process of risk mitigation, trying to figure out the source of the high risk and ways to reduce this risk. By conducting sensitivity analysis, the project manager can know exactly which risk is the most one that's impacting his cost, and he can later conduct mitigation analysis. But this does not mean that the risk mitigation is feasible or cheap for this specific risk. In conclusion, this paper has experimented mainly quantitative risk analysis. However, a new approach called risk prioritization using risk drivers could be used, where interviewee is asked about actual risk, not about each line item. Those actual risks can have different results on several line items. It's also important to note that one of the most important concepts is the integration of cost and schedule risk analysis together. Also, another way for risk mitigation, which is the integrated project delivery and BIM, which has presented some promising results. Thank you.